Alright guys, welcome to day 19. We're going to dive right in by looking at how to add and subtract rational expressions. This is the last major topic of kind of what I consider to be the prerequisite material for college algebra. This is basically what we cover in the first 2 weeks of my college algebra class, because you have to know everything we're talking about in order to do college algebra effectively. There are a few rules to talk about today, and you'll notice that there's similar trends in a lot of what we're talking about as we finish these problems. Do note how those fit together and the big differences between today's problems versus last time's problems. Let's get started. Okay, first of all, there is a 5-step order of operations to solving adding or subtracting rational expressions. First, just like before, you need to factor the numerator and the denominator. This is a must. It has to be done every time. Second thing, now what you need to do is you need to find the least common denominator for the expressions. We'll get into more of what this looks like, but it is a very important step, and one that you're probably pretty familiar with if you remember any of your pre-algebra stuff. Third thing, you want to multiply by expressions equal to 1 such that the denominators change to least common denominators, or LCDs. Step 4, we want to actually, add or subtract the functions. And finally, we want to simplify. Let's talk about each one of these in turn by looking at something really basic. In this case, my basic thing is going to be two fractions that have numbers in them. So if I want to add together 3/4 plus 4/5. If I want to add these two fractions together, I can follow these exact same steps, but do note that in this case, it's less common to do it this way. These are the steps you can use, but it's just less common to do so with numbers because there's easier ways. So what I can do is I can convert all of these into factors. So this first one is 3 over 2 times 2, and then 2 times 2 over 5. So this is my factored form. Now what I want to do is I want to find the least common denominator. What that means is I want to look at this bottom row and see if there are any that only appear once in each set. In this case, I can see I have a 2, and a 5. These are my least common denominators. I have 2 2's in the left one. If there had been 1 2 here and 1 2 here, I'd only put a 1 2 here because it's what they have in common. This has 2 2's, so I put down 2 2's. This has 1 5, so I put down 1 5. So these are my least common denominators. Now what I want to do is I want to take each of these fractions in turn. So the 3 over 2 times 2 and the 2 times 2 over 5. I want to multiply them by a specific fraction that is the least common denominator, is what I want to be my output. So this first one, the thing that's missing is the 5. So I can do 5 over 5. The thing this one is missing is both the 2's. So 2 and 2, 2 and 2. Note, I'm multiplying by an expression that is equal to 1. 5 divided by 5 is 1. 2 times 2 over 2 times 2 is 1. And so this first piece holds, but my goal is to get it to match the least common denominator. I have 2 2 5 now in the denominator. I have 5 2 2 now in the denominator. Those match the least common denominator. Now what I can do now is I can add or subtract these expressions. So I have 3 times 5 plus 2 times 2 times 2 times 2 all over my least common denominator, which is 2, 2, and 5. Now my last step is to simplify. So I want to take this fraction and simplify it down. 3 times 5 is 15. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 times 2 times 5, that would be 20. And then we simplify some more, becoming 31 over 20. And this is our answer. Notice how we follow these steps when we're doing it with basic fractions, and we're going to follow these steps still when we do it with more complex fractions involving rationals. So, this is my initial problem. Notice I factored my pieces. This allows me to determine what the least common denominator is, because I have 2 2's here and a 5 here, so it would be 2, 2, 5. Then I can multiply by a fraction that will get it to become the least common denominator. 2, 2, 5, 5, 2, 2. They both have the least common denominators. But again, I have to multiply by fractions that are equal to 1. So I use 5 over 5 to make this 2, 2, 5. I use 2 times 2 over 2 times 2 to make this 5, 2, 2. And again, the order of the multiplication is not important because order of operations is commutative. Finally, then I actually do the property of adding and subtracting. Now I could have, of course, simplified here, right? And I could have, of course, simplified earlier. But I'm just trying to maintain the same properties that I would have before. And then you simplify as far as you can. This end result did not need to be simplified any farther because 31 divided by 20 does not simplify. But if it does simplify, we would take one more step to do so. With this basic example in mind, let's look at one involving variables. This is my first example. 5 over x plus 6 over y. Now, I'm going to take my first step, is to factor. But that's not very useful because factoring doesn't really do much here. If I factor this, it would become 5 over x plus, 2 times 3 over y. And in this case, the 2 times 3 isn't like the top ones where it's going to matter too much, because really you're concerned with denominator especially being factored. The big one is to factor the denominator. If the numerator is factored, that's less important. So this one's the big one. You need to factor your denominator. The other one is more of a meh. Okay, now here. I want to now multiply by a specific fraction after I find the least common denominator. Well, I notice in this first one, I have an x only in the denominator. Now I want to look at my second one. If I have an x, I can skip adding another x because I don't want to have too many. I want to have the least. But I notice it does have a y. So in this case, my least common denominator is going to be xy. Now I want to take my next step to be multiplying by a specific fraction for each one of these to get it to have that least common denominator. Now this first one, what it's missing is a y. So I multiply by y over y. Notice that y over y is 1, which is acceptable. And this forces my denominator to change to the least common denominator, which is xy. Over here I have 6 over y. What it's missing is the x. Again, x over x is 1, so that property still holds true. And I have now converted the bottom to the least common denominator when I put it in order. Last step is to actually add these together. So 5 times y plus 6 times x over xy. And then we look to see if we can simplify anything. In this case, there is no simplifying to be done. So this is the final answer. You might put it in a different order. You might put y second and x first, because remember you can switch around the order of the top. But this is an acceptable answer based on every property we've done. We factored the numerator and denominator. There wasn't much to do there, especially the denominator is what's important here. Part 2. We want to find the least common denominator. We did that. It's what's missing from each one to make them match. This fraction is missing the y. This fraction is missing the x. We then multiply by those expressions to make them match using a factor of 1. So y over y, x over x. It forces the denominator to become xy. And then we actually do the addition or subtraction, so 5y plus 6x, 5y plus 6x. The denominator is just xy. Remember, when you add fractions together, the denominator stays the same. You're just adding the tops, or subtracting the tops. And then the last step is to simplify. This didn't have to simplify any, so this is a good first example in terms of what ease looks like. Let's do one more simple example. In this case, my example is going to be y over 2x minus x over 4y. Okay, this is beautiful. All right. I want to see if I can factor any of this. It turns out factoring is not the best one for a lot of the easy problems. So let's move on to step 2. I want to determine the least common denominator. Well, in this example, I have 2x, and my bottom here is 2 times 2 times y. So I have 1, 2 that they share, 1, 2 that they do not share, an x they do not share, and a y they do not share. So this would be our least common denominator. Notice I don't put 3 2's because they share a 2, so I cancel one of the 2's out. I only put the least common. So I have 1, 2, a second 2, an x, and a y. 1, 2, a second 2, x, and y. Now, next step. I multiply by fractions that will get me to this least common denominator. My first one is y over 2x minus. My second one is x over 4y. So what is this first one missing? This first one is missing one of the 2's and the y. So there's my fraction I'm going to use. What's the second one missing? It's just missing the x's. It's already got the 2 times 2 written as a 4, and it already has the y, so what it's missing is the x. Now, I actually do the addition and subtraction. So this is y times 2y minus x times x. On bottom, I'd have either 2x times 2y, or I'll actually use this one, 4yx. And the last phrase is to simplify what we can. So on top, y times 2y would be 2y squared minus x times x is x squared all over 4yx. I'd actually put it in the correct order, 4xy. So there's an example where we have these conflicting bottoms that end up needing a least common denominator. Note, we want to have the least common denominator. Having a common denominator is one thing, but if you have a least common denominator, it saves a lot of time at the end. Let's look to a more advanced example. Hopefully these are ringing some bells that you may have seen these before. Let's look at one involving where we have to actually factor some. In this case, we have an example of 6 over x squared plus 4x plus 4 minus 2 over x squared minus 4. Here's where it becomes really important to make sure you factor on your first step. So step 1, I'm going to factor this. On top is just going to be a 6. Like, the numerator is not that important. What matters is that we factor the bottom correctly. So this bottom piece, I actually recognize this as a perfect square formula, which saves me some time in my factoring. Oh, so that would be 2, not 4. This would be x plus 2 times x plus 2, or x plus 2 squared. And then over here, I recognize this as difference of squares, which would be x plus 2 and x minus 2. This is where it's really important to look for your least common denominator. Because if you fail to look for your least common denominator, this can get really nasty really fast. In this case, I see I have an x plus 2 in each of them, so I put down 1x plus 2. I have a second x plus 2 that is not in the first one. This one is already counted, right? So I've already used these, which means I need the x plus 2 to be added in, and I need the x minus 2 to be added in. So in this case, a least common denominator would have 3 components, x plus 2 and x plus 2, which covers the first one. So this contains the denominator of the first one, and this one contains the denominator of the second one. So notice how if they have one in common, you only put one of them, not both of them. But if there's ones they don't have in common, like this second x plus 2, I have to put in the list. This individual x minus 2, I have to put in the list. Step 2. I found my least common denominator. So I'm going to move on to step 3. I'm going to multiply by the expression. That's going to make this equal to 1. So for my first one, 6 over x plus 2 times x plus 2. The thing that I'm missing from this list is the x minus 2. So I'll put the x minus 2 in. Minus. On my second one, 2 over x plus 2, x minus 2. The thing that I'm missing is the other x plus 2. So now you can see on the denominator for each of these I have the same three pieces, x plus 2, x plus 2, x minus 2, x plus 2, x plus 2, x minus 2, x plus 2, x minus 2, x plus 2. I have all three pieces. Not necessarily in this order, but I have all three of them. And note that I always multiply by a fraction that is equivalent to 1. Now that I'm here, I'm going to take my next step, which is going to be to actually distribute and then start subtracting. So 6 times x minus 2 is just 6x minus 2. 2 times x plus 2 would be 2x plus 2. On bottom, I have x plus 2 times x plus 2 times x minus 2. I can put these in any order. I chose to go with the first order because it's matched to my least common denominator. It doesn't matter that much. Just make sure you get all three pieces because this is what's important. Now, this is the actual subtraction component. Now I need to see if I can simplify anything, and there is stuff to simplify. Now, a note on the simplifying rule. It is not necessary to simplify the denominator. I firmly stand against simplifying the denominator. Do not simplify the denominator. Just simplify the numerator as far as you can. That is because the denominator is just excess work, and we'd rather leave it in this form if possible. So, on top, I distribute the 6 to both terms. I distribute the negative 2 to both terms, giving me 6x minus 12 minus 2x minus 4 all over x plus 2, x plus 2, x minus 2. Okay, now I simplify some more. I have 6x and negative 2x, which becomes 4x. I have negative 12 and negative 4, which becomes negative 16, all over x plus 2 times x plus 2 times x minus 2. The only thing that matters is here at the end, refactor the numerator. You simplify the numerator, refactor it, because there's a chance it can cancel like we did last time. So on top, I have 4x minus 4 over x plus 2, x plus 2, x minus 2. This, since nothing cancels, is the accepted final answer. If one of these pieces had canceled, we'd cancel it and write that as our final answer. Remember, the word simplify now implies a whole host of different processes you can use. So make sure you go through those steps and find those pieces. In this case, I have the following components left over. I have a 4, which I factored out. I have an x minus 4 in the numerator. In the denominator, I have my least common denominator, x plus 2, x plus 2, x minus 2. Nothing cancels, so this must be the final solution. So this is an example where you have to factor because something is in common. These are some of the ones you have in class for your homework, but there are also ones that are easier. And so let's look at one of those as well. Example, sorry, 3 over x plus 5 plus 1 over x minus 3. So, in this case, it's important to note that these pieces in the denominator are parenthesed automatically. That's part of being in a fraction. I want to see if I can factor any of these. Well, this bottom piece doesn't have a factor. This bottom piece doesn't have a factor. These top pieces also don't, but remember, the tops are less important. So now I look to see what's my least common denominator. Well, from the first one, I would have to have an x plus 5 to make them common. From the second one, I'd have to have an x minus 3 to make them common. Notice they don't have any pieces currently in common. Common means they're shared, right? Over here, they shared an x plus 2, so I only put one of those x plus 2s into my least common denominator. I got a second one because there was a second x plus 2, and I got the x minus 2 because there was an x minus 2. If they share one, if there's one in common, you only put it once. But each unique thing needs to be put in to the second time. So I see I have my two unique ones there. So in this case, I'd have 3 over x plus 5 plus 1 over x minus 3. I need to use my fractions. Now, for this first one, the piece that it's missing is the x minus 3. So I do x minus 3 over x minus 3. The piece this one is missing is the x plus 5. So I do x plus 5 over x plus 5. Now again, you'll notice the denominators for each of these match my least common denominator. Now I can start multiplying and then do the operation. So 3 times x minus 3 would be 3 times x minus 3 plus 1 times x plus 5 all over x plus 5 times x minus 3. So you can see how the pieces from this first one are right here, pieces from the second one are right here, and the common denominator is on the bottom. Last step, I want to simplify what I can, and then see if I need to cancel anything. So I distribute the 3. 3 times x, 3 times negative 3, 1 times 5, 1 times x. So 3 times x would be 3x. 3 times negative 3 would be negative 9, plus 1 times x would be x. 1 times 5 would be 5, all over x plus 5 times x minus 3. Notice I'm not simplifying the denominator because it's not useful. On top, simplify what we can. 3x plus x would become 4x. Negative 9 plus, plus 5 would become negative 4, all over x plus 5, x minus 3. I'll factor what I can, so I can factor the top to have a 4 come out. And on bottom, again, since there's nothing in common that I can cancel, this ends up being our final solution. You always want to look for these components, these pieces that end up having that fraction that can work. Let's go ahead and do one of your homework problems, I guess. Most of your homework problems are in this category, which is nice, but that's not always the case, so make sure to note, especially when they don't have anything in common, how to fix that. Let's look at number... Simplifying gets fun. Let's look at 38. So number 38 is one of your homework problems. You won't have a whole lot of homework problems, right? Just 9. Let's look at number 38. On number 38, we have x minus 1 over x plus 1 minus 2x plus 3 over 2x plus 1. I look to see if there's any factors. That's step 1. There are no factors. So now I move on to step 2. I want to determine that least common denominator. In this case, I have, from the first fraction, x plus 1. From the second fraction, I have 2x plus 1. They are different, so I'd have both of them. Next step, I'd want to now multiply by x minus 1 over x plus 1. I want to multiply each fraction by the one fraction that will cause them to match least common denominators. So in this case, I multiply by 2x plus 1 on top, 2x plus 1 on bottom, minus 2x plus 3 on top, 2x plus 1 on bottom. And I take the second one and multiply by its respective fraction, which is x plus 1 over x plus 1. Okay. Now we actually do the multiplication and we do the subtraction. So on top we have x minus 1 times 2x plus 1 minus 2x plus 3 times x plus 1 all over. On bottom you'd have 2x plus 1 and x plus 1. So x minus 1, x minus 1, 2x plus 1, 2x plus 1, minus, 2x plus 3, 2x plus 3, x plus 1, x plus 1. And the common denominator ends up on bottom. Now, we just have to simplify what we can. On top, I can use FOIL on each of these pieces. On bottom, just leave them the way they are. Don't bother simplifying the bottom. The denominator is just fine the way it is. On top, if I simplify this, I would end up with 2x squared minus x minus 1 minus, this would become 2x squared plus 5x plus 3. And then we need to distribute the negative sign. This becomes 2x squared minus x minus 1 minus 2x squared minus 5x minus 3 all over 2x plus 1 times x plus 1. I then simplify what I can. The 2x squareds and 2x squared are going to cancel. We have negative x and negative 5x, which will have negative 6x. We have negative 1 and negative 3, which become negative 4, all over 2x plus 1 times x plus 1. Now I do want to factor this top piece. I'll take a negative 2 out, leaving 3x plus 2, because there's a chance, a very small chance, but a chance, that it simplifies farther. And since nothing simplifies, this is the final solution. There is at least one problem in your homework where once you get here, something cancels, and you should simplify as far as you can. But otherwise, that makes this our final solution. So, this is the last day that we have for these assignments. Next week, we will have a quiz over the material from the last week and a half. We will then do 2 days of graphing, and then there'll be your final. Your final will likely be dropped Wednesday night. That way you have time all day Thursday to work on it and get it back to me. Remember, it is due, it's going to be due on Friday at the normal time, is my current plan. If that changes, I will make an announcement on there and say it during videos. That should be it. I'm debating whether or not the graphing portion will be actually on the final itself, because it wasn't on the pre-test. But it is something that needs to be taught, and so we will talk about it significantly for at least 2 days for next week. I've been meaning to do it. It's one of those things that always bugs me that more algebra students don't have coming in, is good graphing skills. They can grab a graphing calculator for days and graph it with that, but if you can't graph it by hand, there's something lost in the translation. And most of you should be taking college algebra because you want to either go to school for a science or because you're hoping to get into calculus. In which case, if you can't graph, calculus becomes very, very difficult. So, that'll be it for today. Your homework assignment consists of 9 problems, one of which was done here. And don't forget our Zoom session today at 1 p.m. See you guys then. Bye.